In this video, we'll learn how to identify a function given a relation. Let's first review our definition of a function again. Remember, a function is just a relation in which each input from the domain results in exactly one output from the range. In other words, each individual input is paired only with one output. Does the following relation represent a function? Here we have a relation that consists of three ordered pairs. The first one is the ordered pair 2, 4. The second one is the ordered pair -3, 1/2. And the third is 1, 1. In order for this to be a function, each input can only be paired with one output. So when we look at our first input, 2 is paired with 4. And as I survey the other two ordered pairs, I see that 2 is not paired with any other number other than 4. So far, so good. Now let's look at our second ordered pair. The second ordered pair is -3, 1/2. And in this ordered pair, the input 3 is paired with the output of 1/2. Again, for this to be a function, -3 can only be paired with 1/2. When I look at my first ordered pair and my last ordered pair, I see that -3 is not an input in either of those ordered pairs, and therefore -3 is only paired with the output of 1/2. So this is still considered a function at this point. And now let's check our last ordered pair. This ordered pair shows us that an input of 1 is paired with an output of 1. Again, in our first and second ordered pairs, we see that neither of those contain an input of 1 paired with a number other than 1. So because 2, -3, and 1, the inputs in our relation, are only paired with 4, 1/2, and 1 respectively, and aren't paired with any other numbers, then this does represent a function. Does this relation represent a function? Well, let's see. -1 is paired with 4. For this to be a function, an input of -1 can only be paired with 4. As I look down here at my last ordered pair, I see this ordered pair tells me that -1 is also paired with 14. Well, because -1 is paired with 4 and -1 is paired with 14, this is not a function. So when you're looking at a relation, an easy way to tell if that relation represents a function or not is to look at all of your inputs. If your inputs, any of your inputs are listed twice in the relation, then what we're looking at does not represent a function. In this case, -1 was listed twice as an input and was paired with 4 and 14. So this is not a function. So this one's a little different. Does this relation represent a function? In this relation, I see 1, 2, 3 ordered pairs. Now, according to the previous example that we did, we should be able to look at each one of these ordered pairs to see if an input is repeated. And I see that an input is repeated. The blue circle input is used twice. In the first ordered pair, the blue circle is paired with the yellow smiley face. And in the third ordered pair, the blue circle is paired with a red triangle. Well, if an input is paired with more than one output, this does not represent a function. So no, this one does not represent a function. In this example, we have a little bit different representation of a relation. All of the elements on the left side of the screen are elements of our domain, and all of the elements on the right side are elements of our range. The first element of the domain is pi, and I can see that if I follow the arrow here, that pi results in a -b in our range. So that gives us the ordered pair pi -b. The next element from the domain that I see is e, and I see that E is paired with Z from the range. That would give us the ordered pair E, Z. The third element of our domain that I see is I, and I see that I is paired with 2. That gives us the ordered pair I, comma 2. But I also see that I is paired with tree. So that gives us the point I, comma tree. Now, based on what we see here, does this relation represent a function? And the answer to that is no, because I see that I is paired with 2 and it's paired with tree. Well, that can't happen if this is a function. So therefore, this is not an example of a function. Does this relation represent a function? Pause the video right here. See if you can do the work yourself. And then unpause the video and see if you got it right. So go ahead and pause the video now. All right, so hopefully you've done the work yourself and you've identified whether or not this relation represents a function. Let's see what we have. The first element of our domain is 1, and I can see that 1 is paired with 2 from the range. That gives me the ordered pair 1, comma 2. The next element in our domain is -2, and we can see that -2 is paired with 2 as well from the range. And then last but not least, we see that 3 is paired with 2 also. So this gives us the 3 ordered pairs, 1, comma 2, -2, comma 2, and 3, comma 2. Remember, the definition of a function says that each element from my domain is paired with 1 element from the range. 1 is paired with exactly 1 element, 2. -2 is paired with exactly 1, 2. And 3 is paired with exactly 1, which is 2. So this does represent a function. There's nothing in the definition of a function that says that each individual input can't be paired with the same output. So this does represent a function.